All right, here we go. Sorry. So, we're going to start out with some reasoning. And we're going to talk about the corresponding angles postulate. Okay, so you can all breathe a sigh of relief, though, because we don't have to prove postulates, right? Postulates, we just kind of are things that we accept to be true, all right, without needing to prove them and stuff like that. Because if they weren't true, then lots of things would give us we'd have lots of problems that we'd have to deal with. Okay, it would kind of make math more illogical. The postulate states that if two parallel lines are cut by a transversal, then corresponding angles are congruent. Okay, so there it is, officially now written out, okay, a fact for us to use, a postulate for us to use. Corresponding angles postulate. Okay, so now we can use this just like we do the segment addition postulate when it shows up in a proof, angle addition postulate when it shows up in a proof, corresponding angles postulate. We can say guaranteed they will be congruent. Okay, so that leads us into the alternate interior angles theorem. And now you can all groan because a theorem is something that we can prove. Hooray, okay? Theorems must be proven, right? Okay, so draw a little diagram here. And I'll number some things. Okay. Forgive my numbering. Okay, I'm gonna number things in a bit of a weird way. So please do match my numbering, but it doesn't really make any sense about how I'm numbering things here. So forgive me, please. All right, given A is parallel to B. Line A is parallel to line B there. Okay. Given that line A is parallel to line B. If I wanted to at this point, because I know that information, I could, as part of my work, put the little parallel symbols in there if I wanted to. Okay. It's given to us right there. It's up to you whether you want to mark it on there or not. Again, I always like to mark my pictures and things, but you don't have to. Okay, so given that line A is parallel to line B, we're going to prove angle 5 is going to be congruent to, well, if we're trying to prove the alternate interior angles theorem, we want to prove in this case that angle 5 would be congruent to what other angle? It's got to be 6, right? Angle 6 and angle 5 are alternate interior angles. So our goal then in this case is to prove that angle 5 is equal to congruent to angle 6. And then we won't do the other proof, but by a very similar proof, we'll be able to, you can prove that angle 2 is congruent to angle 1, should you want to. Okay? So let's get into this proof here. So I'm going to make, let's see here, can I fit it? I think I'll be able to fit it. So we'll make a 2-column proof here. Statements, reasons. Okay. Manual question? Oh, sorry. I'll zoom it in there for you. There you go. I'll let you get that real quick here, and then we'll do that. Okay. Good? Okay. All right, so, again, back to our statements and reasons. All right, where do we always start with our proof? The given, right? So we're going to restate our given here. A is parallel to B. Why do we know that's true? It's given. Okay. So, the next step I'll give to us here, we'll say that angle 6 is congruent to angle 7. How do we know that angle 6 and angle 7 are congruent? Must be congruent. Yeah, not the alternate because we're not there yet, right? They're corresponding, right? The corresponding angles postulate, okay? So I'm going to abbreviate here just because corresponding angles postulate just kind of saves space. Okay, corresponding angles postulate. They must be congruent. Okay, so 6 and 7 must be, and there's other ways to kind of prove this. This is just kind of one path to take. All right, I'm going to say something else. Angle 7, I'm going to say, must be congruent to angle 5. Why must angle 7 and angle 5 be congruent? According to the diagram there. Why must angle 7 and angle 5 be congruent? Based on what, Luke? Yes, vertical angles. Whoops. Yep, you can say definition of vertical angles. I'm just going to say, and I'm going to abbreviate again. Vertical angles are congruent. Okay, they're vertical angles, so I just said vertical angles are congruent. That's fine. You can say definition of vertical angles. That's okay too. Okay. Now let's look at what I've established here. I've established that 6 is congruent to 7. I've established that angle 7 is also congruent to angle 5. And I'm trying to show that angle 5 is congruent to angle 6. Well, if I have these two congruences, can't I now say angle 5 must be congruent to angle 6? By the transitive property, right? Or if you want to use substitution, that would be fine too. Okay, I'd be fine with either one there. We established that 6 and 7 were congruent. We established that 7 and 5 were congruent. Since 6 is congruent to 7 and 5 is congruent to 7, then that means 5 and 6, angle 5 and angle 6 must be congruent. Voila. We've proven that alternate interior angles will always be congruent. Will always be congruent. Okay? Questions on any of that? All right, we're going to do the same thing for alternate exterior here. Oh, so I guess I'll just say, let me state the actual alternate interior angles theorem here, sorry. If a transversal cuts two parallel lines, I really should use intersect there, not cuts, that doesn't really, but anyway. Then the alternate, I'm going to abbreviate here, interior angles are congruent. Okay, if a transversal cuts two parallel lines, then the alternate interior angles are congruent. That's the actual alternate interior angle theorem there. Okay, and then I'll have you guys do the alternate exterior angle theorem. Don't worry, I'll have you fill in some stuff. Okay. Okay, so we'll just use the same picture as above here. We'll just use the same, I think we'll use the same picture. Let me just check to make sure I did that. I think I did that in the past. Okay, sure. We'll just do that here. So we'll use the same diagram as up here. Given A is parallel to B, let's prove that, I don't know, angle 4 is congruent to angle 7. Okay. So again, I'll give you the statements for this one. We're going to use the same picture as we did right here. I'll give you the statements for this one, and then you give me the reasons. So I'll leave the picture up there for you to see as well. But go ahead and fill in those reasons. All right, Maddie, number 1. What did you give the reason for that one? Given. Okay, very good, Maddie. Okay, let's go to Eli. How about the next one there? Corresponding, so that'd be the corresponding angles postulate. Okay, very good, Eli. Well done. How about Jenny? What do you say for 5 and 7? Very good, Jenny. Exactly right. Okay, good. And then last one, let's go to someone who's here. Let's go to Jackson.
Substitution.
Yep, substitution property or transitive property there would be fine. Either one. Aha, so now we have alternate interior exterior angles. So if a transversal, I'm going to use intersects now, intersects 2 parallel lines, then again I'm going to abbreviate, alternate exterior angles are congruent. You must have those 2 lines are parallel in order to use the fact that alternate exterior, alternate interior corresponding angles are congruent. Okie dokie. Questions on those? See how hard are those proofs? Those proofs are easy. You guys are like, Miss Wimmeyer, you're filling in half of them for us. Yeah, I know. All right, let's do another one. Last proof we need to do here. Corresponding angles. Wait, not corresponding, sorry. Co-interior. Co-interior. Okay, or same side or co-interior. Okay, same side or co-interior angles. Okay. Theorem. All right, so again, we'll do the same picture, use the same picture, or a similar picture, obviously. Here, I'm not going to. Okay, so it's A and B, and we'll number it. Okay. So now we'll start with the given. Still being A is parallel to B, but now we're going to prove. Remember what we said, co-interior was unique. Co-interior were supplementary, and so we have to now establish that co-interior angles add up to 180 degrees. Let's just, again, for the sake of this piece, we'll say angle 1 and angle 5 are supplementary. Okay, a little bit different than trying to prove equality here. We're trying to prove that angle 1 and angle 5 are supplementary. Right? They add up to 180 degrees. And of course, a similar kind of argument could be done for 6 and 2. So again, we'll do our statements and reasons. And I'll do it below here so that way it won't go off the screen. And so for the first statement, we'll say that A is parallel to B. And the reason is it's given, right? That's obvious enough. Again, I'm going to give you the statements here, but then I'm going to ask you guys to help me out with the reasons, right? Okay, so next statement. Okay, there's our first statement after the given. We're saying that angle 4 is congruent to angle 5. All right. So let's see here. Lucas, can you give me a reason why we're going to maybe say here that angle 4 is congruent to angle 5? What can we maybe use to say that? Corresponding, exactly right. Okay. Again, I'm going to abbreviate corresponding angles postulate. Okay, corresponding angles postulate. Okay, good, well done. All right, now we're going to say the measure of angle 4 therefore must equal the measure of angle 5. Why can we say that, Jenny? Very good. We've gone from stating two things are congruent to then stating their measures must therefore be equal. That is the definition of congruence. Okay? Remember, when we state that two things are congruent, we're saying that they are identical objects. Identical objects. Angle 4 and angle 5, those angles would be the same if you transform them to match over top of each other. They would match up perfectly. So therefore, since they match up perfectly, that means that their measures, the value we attach to the angle measure, would then be equal. And so that's the definition of congruence. All right, great. Good job, Jenny. Okay, so the next thing we're going to say here is that angle 4 and angle 1, and that looks like a 4 that I just wrote there, all right, are a linear pair. Okay? Angle 1, angle 4, and angle 1 are a linear pair. Well, that's kind of given to us in the picture there too, right? I mean, based on where the 1 and the 4 are, we can say that's just given. Okay? We can just say it's given. You also could have maybe used the definition of linear pair there too as an example. So I'll put that here, or definition of linear pair, because it fits the definition. 1 and 4 fit the definition, right? They're adjacent and they make a straight line. Okay? So then, since angle 4 and angle 1 are a linear pair, what can we say about their measures? They must what? The measure of angle 4 plus the measure of angle 1 must equal 180 degrees. And that, again, we could say is from just the definition of linear pair. Or I can just say that linear pairs are supplementary. Or you say by definition of linear pair, that's fine too. So one of those two. All right. So let's recap. We're trying to show that angle 1 and angle 5 are supplementary. That means we need to show that they add up to 180 degrees. We started by stating our given, A is parallel to B. We said that angle 4 is congruent to angle 5 because corresponding angles postulate, right? They're going to be congruent. They're corresponding. Therefore, they're measures. Measure of angle 4 equals the measure of angle 5 by definition of congruence. We then went down a different path and said that angle 4 and angle 1 are a linear pair. And therefore, that the measure of angle 4 plus the measure of angle 1 equals 180. Can anyone see what the next statement is going to be here? What will it be? Okay. Let's go ahead. Daniel, why don't you give it a shot?
The measure of angle 5 plus the measure of angle 1 is 180.
Okay, very good. Jenny, is that what you're going to say too? Avery, is that what you're going to say? Madison, is that what you're going to say too? Good. Excellent. Great job. Yes. Yes. We just stated earlier that the measure of angle 4 and measure of angle 5 are the same. We're trying to prove that 1 and 5 are supplementary, and so we're going to swap the angle 4 for angle 5 using substitution. And then finally, I guess, again, technically we could stop here because everyone understands once we see that, we know they're supplementary, but I'm going to go ahead and state it explicitly. Angle 5 and angle 1 are supplementary. Okay, and now we can finally say both, for the reason both add to 180 degrees. Okay, you could also use definition of supplementary there if you wanted to instead. Okay, that was a fun proof, right? 7 steps. Said no one ever. Okay, so there it is. Okay, and so then just the last thing that I have for us here. So there we've proved all those things. You're like, man, that's good, because that was going to keep me up at night, Mr. Widmeyer, if we didn't actually prove those. Don't want to just use things willy-nilly that we haven't proved, So here's some questions for you to answer. And if you want to write these down, you can. If you just want to do them like from what you see on my paper, that's fine too. Okay? So it's up to you. So state the postulate or theorem that justifies the statement. Okay, I'm going to give 4 statements. So 1, angle 6 is congruent to angle 7. I'm going to give you a picture over here too in just a sec. So 2, angle 5 is congruent to angle 6. 3, angle 4 is congruent to angle 7. And 4, the measure of angle 1 plus the measure of angle 5 equals 180 degrees. And here is your picture. Notice I'm putting in the little marks here to show that these two lines are now parallel. So you can take advantage of all those relationships that we had. Okay, and again, if you want to write this down, you can. If you just want to like do them, that's fine too, like in your head. And then when I call on you, you can just let me know what your answer was. That's fine. Okay, you don't need to write these down if you don't want to. You know, maybe it's just like, what's the point kind of thing for these. Okay. So just think about. Think about here. All right, Madison, number 1 there. What do you say? What postulate or theorem justifies the statement that angle 6 is congruent to angle 7?
I wasn't sure, but I went with co-interior angle.
So are 6 and 7, are they co-interior angles?
No,
So what would it be?
they're not alternate exterior.
Correct, because one's on the inside, one's on the outside.
Corresponding.
Yeah, they're corresponding. They're in the same position, right? Yeah. So corresponding angles, and that's the postulate, right? That's when we started out with the postulate. So it's corresponding angles postulate. Okay. So you kind of see what I was shooting for there now?
Yeah.
Okay. Let's go to Caroline, number 2. How can we say, or what postulate theorem allows us to say that angle 5 is congruent to angle 6? You got it. Good job. Alternate interior angles theorem. Okay, cool. Good job, Caroline. All right, how about Jake again? Jake, angle 4 and angle 7. How can we say that they are congruent?
Alternate exterior.
Yes, sir. Alternate exterior angles theorem. Okay, great. And then last but not least here, let's go to Olivia. Olivia, how can we say that measure of angle 1 plus measure of angle 5 is 180? Co-interior angles theorem. Okay, so these provide justification for us to do, to make these statements. All right, last bit here, last bit. We want to also be able to set up algebraic equations. So we'll just do 2 real quick here. Okay, super quick, and then we'll get you started on your assignment. Okay. Okay, and I'll zoom in on that here too. Some more. And I'll put those arrows there to show that they are, in fact, parallel lines crossed by a transversal. Okay, so there's our picture. Take a look at that. Okay, try to establish there in your mind, if there's a special angle relationship here, right? Could we describe these as vertical, linear pair, corresponding, alternate interior, alternate exterior, co-interior? Try to identify what, special angle relationship that might be there, and then how to then set up an equation based on that information. Just think about that right now. Okay. What is the name for that special angle pair of those two? That pair of angles there. Okay. All right. So, Stephen, what do you say here? What would we call those two angles, given where they are? What would we give the name for that pair of angles?
Alternate interior.
So alternate interior would be that if the 55 were over, sorry, it's frozen. If the 55 were over on this, no, there we go. If the 55 were on the other side of the transversal, but you'll see they're on the same side.
Okay.
So which one would it be?
Linear pair.
Okay, linear pair, they're not next to each other though, right? This and this, they're not sharing a side. I mean, I guess they share this side, but they're not like next to one another. They don't have the same vertex, I guess I'll say. So not linear pair. You want some help?
Yeah.
All right, help us out. What do we do? What is this called? Jake? Co-interior, right? Co-interior, or same side interior, if you want to call it that. Same side interior angles. Okay, now, can you help us out here, Stephen, at least? How should these then angles be related? What did we just say? Co-interior angles, they what?
They equal to 180.
They add to 180, exactly right. So, set up the equation for us. What are we going to write?
7x minus 15. Is it what I say plus 55?
Correct, yes. There you go. Great job. Well done. They add up to 180. Okay, and so now we'll just combine like terms and solve. Minus 15 in the 55 makes 40. Subtract 40 on both sides, you get 140. Divide both sides by 7, you get x equals 20. Okay, we're only asked to find the measurement or the value of x, so we can stop there. We don't need to plug back in and get the measure of this angle. Okay, so it's just 20. Okay, did anyone think about doing that in a different way besides what I just did there? Okay, that's fine. Cool. Last one. I'm off the screen, sorry, thank you. Okay. Those are not to the 0 powers, those are supposed to be degrees. Okay, those are supposed to be degrees. Ugh, I didn't know the arrows very well there. Let's see if I can fix that. There we go. Okay, so with the way that is set up, Emily, what kind of special angle pair do we have here?
That's alternate interior.
That is alternate interior. Very good. And so how can we set up an equation here to start solving for x?
You could do 2x plus 50 equals 3x minus 30 since they're
Yes, very good. Okay, alternate interior angles are congruent, so we can set them equal to one another, and then we'll solve. Can you take us through the solving process here, Emily?
yeah.
Please.
You can subtract 2x from 3x.
Okay, subtract 2x from each side. So you get x minus 30 then.
And you can add 30 to 50.
Good, and we get x equals 80. Okay, and so there is our value, x equals 80. Questions on any of that? All right, so you have the remainder of class time. Get started on your homework here. The homework is on Google Classroom, okay? You're going to do the whole first page of the assignment, and then the second page, there's just one little fill-in proof kind of thing at the top that I want you to do too. Okay, so let's get started on that. Okay, let's get started on that. Okay. And I'll kind of walk around and check to see if you need any help or anything like that.